Hello everyone. Today's lesson is about scientific notation. So let us define it first. Scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in decimal form. For example, building versus house. As you observe, the structure of a building is too large compared to a house. Same with tree versus seedling. Well, if you compare their height, tree is taller than a seedling. Another, Bill Gates' income versus my income as a teacher. As we all know, Bill Gates is one of the richest men in the world. And if we compare my salary to his salary, well, this is extremely huge. If you search Bill Gates' salary on Google, his salary is 119 billion US dollars. And if you convert that into peso, that is almost equivalent to 5 trillion 950 billion. It is very huge, right? Now, how are we going to convert it into scientific notation? So these are the steps that we are going to follow. Step 1. Identify the significant digits. So from what we have studied before, these zeros are trailing zeros and therefore they are not significant. So we only have 5, 9, and 5 as our significant digits. For step 2, you have to write it as a product of a number between 1 to 10 and the power of 10. Since you have to write it in a product of number between 1 to 10, you have to identify the first significant digit, which is 5. And therefore, you have to add decimal point. And since this is a product of a number and the power of 10, then on step 3, you have to identify the number of movements in order to know its exponent. And how will you do that? Since this number is a whole number, then the decimal point is on the right side of the last digit. So we will count from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, the exponent will be 12. So let us have other examples. For number 1, 4,500. This number is not too large, but we can still write this in scientific notation. So first, we must identify the significant digits. So we have 4 and 5. Then, we must also identify the first significant digit, which is 4. So we will add decimal point. So we have times 10. Now what will be the exponent? This is a whole number. The decimal point is on the right side of the last digit. So it's in here. So if we count, we will have 1, 2, 3. So 4.5 times 10 raised to 3, or 4.5 times 10 to the third power. For number 2, 123,000. So again, let's identify the significant digits. And then identify the first significant digit. So let us now try to find out what will be the exponent. So The decimal point of a whole number is on the right side of the last digit. So we have 1, 2, 3, 4, 5. So we will have 5 as its power. So the answer will be 1.23 times 10 to the 5th power. Next, for number 3, 40,000. So we only have one significant digit times 10. So let us count the movement. 1, 2, 3, 4. So 4 times 10 to the 4th power. And for number 4, we have 235. And these digits are significant. So we'll have 2, 3, and 5. And the first significant digit is 2. So we will add the decimal point times 10. So let us count the number of movements. 1, 2. So 2.35 times 10 to the 2nd power. Well, how about this? I searched for the size of the bacteria in Google. This is an example of a very small unit of number. And if you search the size range of a bacteria, it is in micrometer. That is why we cannot see it by our eyes. We can only see it if it is under the microscope. So the size of a bacteria is in 1 millionth. And that is how small it is. To convert this into scientific notation, we just have to follow the steps that we did a while ago. For step 1, identify the significant digit. So since we have here leading zeros, then they are not significant. So we only have 1 as our significant digit. For step 2, you have to write it again as a product of a number between 1 to 10 and the power of 10. So 1 is already a number between 1 to 10. So this will be times 10. Now what will be our step 3? So in step 3, we have to find out the number of exponent. For step 3, we have to count the number of movements of the decimal, which will be its exponent. So let's count 1, 2, 3, 4, 5, 6. And therefore, the exponent will be 6. However, this is a small number. And therefore, our exponent will be negative. So let us have other examples. Since these are leading zeros, then they are not significant. So we only have 5 as our significant digit times 10. And now let's count the number of movements of decimal. 1, 2. So we have 5 times 10 raised to negative 2. For number 2, we have two significant digits, which are 8 and 2. But since we need to find the first significant digit, we will add a decimal point. Because 8 is the first significant digit. Then, we have to count the number of movements of the decimal point. So we have 1, 2, 3, 4, 5. So 8.2 times 10 raised to negative 5. For number 3, we have three significant digits, which are 4, 8, and 2. And the first significant digit is 4. So we will add decimal. So this will be times 10. Now let's count the number of movements of the decimal point. 1, 2, 3, 4. So our answer will be 4.82 times 10 to the negative 4. And for the last one, we have here leading zeros that are not significant. But there is a zero between two significant digits, and therefore 0 in here is still significant. So we have 7, 0, and 5. Now let's identify the first significant digit. So the first significant digit is 7. So we will add the decimal point in here. Now, this will be times 10. So let us count the number of movements of the decimal point. 1, 2, 3. So the answer will be 7.05 times 10 to the negative 3. And that's it. I hope you learned. Thank you.